This is SpaceTime Series 26, Episode 121, for broadcast on the 9th of October 2023. Coming up on SpaceTime, another delay for the launch of NASA's Psyche mission to a metallic asteroid. Scientists examine what causes planet Earth's strongest lightning bolts. And the FAA releases its report on Blue Origin's crash and burn. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Mission managers have rescheduled the launch of NASA's Psyche spacecraft to a metal asteroid, this time for a week to October the 12th. The delay will allow NASA enough time to update the configuration of the spacecraft's thrusters. NASA says the decision to go with a reschedule was made during a flight readiness review. It gives engineers more time to verify parameters used for the nitrogen cold gas thrusters that orient the spacecraft. The parameters required the changes after engineers concluded that the thrusters would be operating at warmer temperatures than what had originally been predicted. Operating the thrusters within temperature limits is essential to ensure the long-term health of the units. The verification work involves running simulations and making adjustments to flight parameters and procedures. This delay will take a week from the mission's 3-week launch window. The spacecraft has daily instantaneous launch opportunities from October the 12th through to the 25th that would allow it to fly its trajectory to the asteroid Psyche. That trajectory was revised last year when the spacecraft missed its original launch date of August 2022. That was because of software testing problems. An investigation into that delay uncovered significant institutional problems at the Jet Propulsion Laboratory which contributed to the slip, and which an independent review panel says has now been resolved. Still, the year-long delay increased mission costs from just under $1 billion to some $1.2 billion, and it pushed back the spacecraft's arrival time of the asteroid Psyche from 2026 to 2029. The Psyche spacecraft will fly aboard a SpaceX Falcon Heavy rocket from Launch Complex 39A at the Kennedy Space Center in Florida. The Falcon Heavy is made up of 3 Falcon 9 core stages strapped side by side. The spacecraft will be traveling some 3.6 billion kilometers in order to rendezvous with the 279-kilometer wide metal-rich asteroid, which is one of the most massive objects in the main asteroid belt between Mars and Jupiter. 16 Psyche is a large M-type metallic asteroid. It was discovered back on March the 17th, 1852, and it's named after the goddess Psyche, one of the most celebrated characters of Greek mythology. She was known as the goddess of the soul. Her name meant breath of life, and she was closely linked with the inner human world. It's said her beauty rivaled that of Aphrodite, the goddess of love. The prefix 16 signifies it was the 16th minor planet to be discovered. It's the largest and most massive of the M-type asteroids and one of the dozen most massive asteroids known. In fact, it contains about 1% of the total mass of the main asteroid belt. Historically, it was hypothesized that Psyche was the exposed metallic core of a small planetary body. A collision with another object stripped away the crust and mantle of the originally much larger differentiated parent body, which would have been around 500 kilometers in diameter. A second hypothesis suggests that Psyche was disrupted and then gravitationally reaccreted into a mix of metal and silicate. Now, if this case is correct, Psyche may well be a candidate for the parent body of a class of stony iron meteorites. The latest hypothesis suggests that Psyche may be a differentiated object, like Ceres or Vesta, but it's experienced ferrovolcanism while cooling. Now, if this one's true, the model predicts that the metal would be highly enriched only in those regions containing relic volcanic centers. And this idea has been bolstered by recent radar observations of the asteroid. Now, scientists from the Southwest Research Institute in Boulder, Colorado, are using telescopes to observe the asteroid in infrared, providing context for NASA's Psyche mission. Stephanie Jarmak's using the James Webb Space Telescope to look for water signatures on the surface of Psyche, while Anicia Arredondo is using some of the last data collected by the Stratospheric Observatory for Infrared Astronomy, or SOFIA Airborne Telescope, to study differences in Psyche's composition at different points on its surface. Previous observations indicate that Psyche is a dense, largely metallic object, originally thought to have been the leftover core of a failed planet. Using telescopes at different infrared wavelengths provides different complementary information as to what the asteroid really is. Still, despite all the attention it's getting now, Psyche remains somewhat mysterious. That's because some of the previous observations have given conflicting results. For instance, showing variability in its surface composition in near-infrared wavelengths, as well as hints of hydration on its surface. And that's interesting because the Webb observations are designed to determine if water exists on Psyche's surface. Jarmak says observations across the 3 and 6 micron wavelength range are telling scientists if hydration is present, either in the form of hydroxyls or as actual water. But of course, if they didn't find it, that wouldn't be surprising, considering Psyche's thought to be a mostly metallic world. Arredondo used the Boeing 747 mounted SOFIA telescope to scan the asteroid in the infrared as it rotated to better understand if Psyche really could be the remnant core of a differentiated protoplanet. Arredondo says if it were, then multiple impacts would have stripped all of the outer layers off the asteroid, leaving only the metallic core behind. But those same impacts could also lead to variability. And the problem here is observations indicate that Psyche is metal, no big surprise there. But there's not a lot of variation with rotation, at least not from what we can see in mid-infrared. Of course, the thing is, metallic asteroids are relatively rare in our solar system, and so Psyche could still offer a unique opportunity to see inside a planet. However, Psyche is so unusual, it could also surprise scientists and suggest a different story of how solar system objects formed. All of the observations using different techniques keep showing results that don't make sense in context with each other. And that's why the Psyche mission is so important. This report from NASA TV.
There aren't many classes of objects left in our solar system that we haven't looked at up close with a spacecraft. And one of them that's left is the metal asteroids.
16 Psyche is an asteroid that orbits the sun out between Mars and Jupiter.
The reason that Psyche is unique is that it is metal-rich.
It's believed that it may be a remnant core of an early planetesimal that was formed in the very, very earliest parts of the formation of the solar system.
And after this planet started forming and this metal core formed inside of that, it collided with other bodies that then stripped off the rocky mantle, leaving this core in place.
This is the part of planets that we can't sample directly today.
It's too hot, the pressure's too high, our instruments would melt. Can't drill a hole that deep in the Earth or other planets. So how do we study the core of our planet?
Psyche gives us the opportunity to visit a core, the only way that humankind can ever do, and it would be the first metal object that humankind has ever visited.
After launch, we cruised through interplanetary space for a number of years. First, we fly by Mars for gravity assist that'll slingshot us into the asteroid belt. And then we're thrusting all the way from there to finally arriving at Psyche.
We'll go into 4 orbits to collect the necessary measurements that we need from our 3 primary instruments.
So our payload consists of a couple of imagers, which are cameras that take pictures of Psyche. Also a gamma-ray neutron spectrometer, which allows us to measure the elemental composition of the surface of Psyche. And then a magnetometer, which will allow us to detect any magnetic field that's left at Psyche.
If Psyche still has some sort of remnant magnetic field, that probably tells us it really was a core. It's a strong indicator. We also use the radio on the spacecraft as an instrument, so we can map out the gravity and map out the interior structure that way.
We're using a particular thruster technology, Hall effect thruster technology. They operate 5 times more efficiently than normal rockets, so they use a lot less fuel, and is what allows us to get into orbit around this asteroid.
Solar electric propulsion has been around for quite a while, and it has flown before, but we're continuing to push the boundaries. We're going to have big 5-panel fold-out solar panels that will provide the electricity for the thrusters, which use as propellant the noble gas xenon.
This will be the first time that Hall effect thrusters have flown in deep space.
Studying the evolution of a planetary body is a detective story.
There's a magic, too, when you actually are on the launch pad and you say, we're go for launch.
And you feel like singing and dancing, and you feel like throwing up at the same time.
Let's go discover things about our solar system that we have no other way to do. I think that it's fundamental to who we are and also who we should be. It's an incredible opportunity to be a part of the team making that happen.
And in that report from NASA TV, we heard from Psyche Mission Image Instrument Lead Jim Bell from Arizona State University, Psyche Mission Principal Investigator Lindy Elkins-Tanton from Arizona State University, Psyche Mission Gravity Science Investigation Lead Maria Zuber from the Massachusetts Institute of Technology, MIT, Psyche Mission Project Manager Henry Stone from NASA's Jet Propulsion Laboratory in Pasadena, California, and Psyche Mission Chief Engineer for Operations David O, also from NASA's Jet Propulsion Laboratory. This is SpaceTime. Still to come. What causes Earth's strongest lightning? And the Federal Aviation Administration releases its report into the crash and burn of Blue Origin's New Shepard last year. All that and more still to come on SpaceTime. Scientists have found that the planet's most powerful lightning events, known as superbolts, are more likely to strike the closer the storm cloud's electrical charging zone is to the land or ocean surface. The findings, reported in the AGU's Journal of Geophysical Research, shows how these conditions are responsible for superbolt hotspots above some oceans and tall mountains. Superbolts make up less than 1% of all the Earth's lightning, but when they do strike, they pack a powerful punch. See, an average lightning strike contains around 300 million volts. But superbolts are 1,000 times stronger, and so they can cause some real major damage. The study's lead author, Avi Ephraim from the Hebrew University of Jerusalem, says although superbolts only make up a very tiny percentage of all lightning, they represent a magnificent phenomenon. A 2019 report found superbolts tend to cluster over the northeast Atlantic Ocean, the Mediterranean Sea, and the Altiplano in Peru and Bolivia, which is one of the tallest plateaus on Earth. Ephraim and colleagues wanted to find out what makes these powerful events more likely to occur in one place rather than another. And their work provides the first explanation for the formation and distribution of superbolts over land and sea globally. Thunderstorm clouds often reach 12 to 18 kilometers in height, and they span a wide range of temperatures. But for lightning to actually form, a cloud needs to straddle the ice line, the region within the cloud where air temperature reaches 0 degrees Celsius. Above the freezing line in the upper reaches of the cloud, electrification takes place and generates the lightning's charging zone. Ephraim wondered whether changes in the freezing line altitude and subsequently changing zone height could influence a storm's ability to form superbolts. Past studies have already explored whether superbolt strength could be affected by sea spray, by shipping lane emissions, by ocean salinity, and even by dust from the desert. But all those studies were limited to regional bodies of water and therefore could only explain part of their regional distribution. A global explanation for superbolt hotspots remained elusive. To determine what causes superbolts to cluster over certain areas, Ephraim and colleagues needed to know the time, location, and energy of selected lightning strikes, which they obtained from a set of radio wave detectors. They use these lightning data to extract key properties from the storm's environment, including land and water surface height, charging zone height, cloud top and base temperatures, and aerosol concentrations. They then look for correlations between each of these factors and superbolt strength, gleaning new insights into what causes stronger lightning and what doesn't. The authors found that, contrary to previous studies, aerosols didn't have a significant effect on superbolt strength. Instead, a smaller distance between the charging zone and either land or water surface led to significantly more energized lightning. Storms close to the surface allow higher energy bolts to form because generally a shorter distance means less electrical resistance and therefore a higher current. And a higher current means stronger lightning bolts. The three regions that experience the most superbolts, the Northeast Atlantic Ocean, the Mediterranean Sea, and the Altiplano, all have one thing in common: short gaps between lightning discharge zones and surfaces. Ephraim says the correlation was very clear and significant. Knowing that a short distance between a surface and a cloud's charging zone leads to more superbolts will help scientists determine how changes in climate could affect the occurrence of superbolt lightning in the future. Warmer temperatures could cause an increase in weaker lightning, but more moisture in the atmosphere could counteract that. So the scientists think there's no definitive answer yet. Ephraim and colleagues now plan on exploring other factors that could be contributing to superbolt formation. Things like the planet's magnetic field and changes to the sun's 11-year solar cycle. This is SpaceTime. Still to come, the FAA releases its report on Blue Origin's crash and burn, and later in the science report, the 2023 Nobel Prizes in Physics, Chemistry and Medicine have been awarded in Sweden. All that and more coming up on SpaceTime. The US Federal Aviation Administration report into the mid-air failure which destroyed a Blue Origin New Shepard rocket has ordered a list of 21 corrective actions which need to be undertaken before the company can fly again.
Command engine start. 2, 1.
Mission control confirms New Shepard has cleared the tower and is headed to space.
The FAA found that the incident on September the 12th last year was caused by a faulty BE-3 engine nozzle due to higher than expected engine operating temperatures. This caused the New Shepard launch vehicle to fail a minute and 3 seconds after liftoff, just as it was entering max Q, the point of maximum dynamic pressure on the vehicle. At this point, the rocket briefly begins throttling back in order to even out stresses on the vehicle, and then it throttles up again. And it was around this point that the New Shepard launch vehicle failed at an altitude of around 28,000 feet.
That BE-3 engine throttled up as we're going to push up to max Q. Again, that's the point where the aerodynamic stress on the vehicle is at its maximum. Throttle back and then continue on up to space.
The launch vehicle's onboard systems detected the anomaly and triggered an abort and separation of the capsule from the propulsion module, and then shut down the main engine.
It appears we've experienced an anomaly with today's flight. This was unplanned and we don't have any details yet.
The capsule was unmanned for mission NS-23 and was instead carrying 34 scientific experiments. As pre-programmed in the event of a booster failure, the capsule quickly undertook an automated emergency ejection, separating clear of any failing booster debris and parachuting safely back down to the ground.
Crew capsule was able to escape successfully. The drogues have deployed, and the mains are going to be pulled out next. All right, the mains are out. They're reefed. They're going to be expanding. As the mains inflate, the capsule will stabilize. That's looking like a successful execution for the crew capsule and escape system. And the crew capsule continuing to descend under its three main chutes. West Texas mountains in the background. As we come down towards the desert floor, we're going to expect that retro thrust system to fire. Again, that will take out most of the energy in the landing in addition to the parachutes. There goes the retro thrust system. Our backup safety systems kicked in today to keep our payload safe during an off-nominal situation.
The remains of the booster appear to have crashed relatively intact on the desert floor. Blue Origin so far carried 31 people into space on suborbital ballistic flights. Reaching space means passing an altitude of 100 kilometres, the Kármán line, where aerodynamic surfaces can no longer control the operation and movement of a spacecraft, and instead some form of reaction engine, like thrusters, need to be employed. Meanwhile, while Blue Origin remain grounded, their competitor in the space tourism industry, Virgin Galactic, has carried out 4 ballistic flights right up to the edge of space. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. The Royal Swedish Academy of Sciences has awarded the 2023 Nobel Prize in Physics to Anne Hullier, Pierre Agostini and Frank Krauss for their separate work on attosecond laser pulses used for studying spinning electron dynamics in matter. An attosecond is a quintrillionth of a second. This new research has given humanity new tools for exploring the movement of electrons inside atoms and molecules, a phenomenon that was long thought to be impossible to trace. See, electrons move so fast that they've been out of the reach of human efforts to isolate them. But by looking for just the tiniest fraction of a second possible, the attosecond, scientists now have a blurry glimpse of them, and that opens up a whole lot of new science. The work will allow scientists to study the subatomic movement of spinning electrons, a field that could one day lead to better electronics and disease diagnoses. Meanwhile, the Nobel Prize in Physiology and Medicine for 2023 has been awarded to Drew Weissman and Katalin Karikó for their discovery concerning nucleotide base modification, which enabled the development of an effective mRNA vaccine against the COVID-19 virus. Their work showed that base-modified mRNA can be used to block activation of inflammatory reactions and increase protein production when mRNA is delivered into cells. The discovery fundamentally changed science's understanding of how mRNA interacts with the immune system, and it's had a major impact on society during the recent COVID-19 pandemic. And the 2023 Nobel Prize in Chemistry was awarded to Mauji Baweny, Louis Braz, and Alexei Ekimov for their discovery and synthesis of quantum dots. Quantum dots are nanoparticles so tiny that quantum effects determine their characteristics. Today, quantum dots are an important part of nanotechnology's toolbox. Back in the early 1980s, this year's chemistry laureates succeeded in creating quantum dots independently of each other. And in 1993, they developed methods for manufacturing quantum dots, keeping their quality extremely high, a vital prerequisite for their use in today's nanotechnologies. A new study is looking at people's attitudes towards daylight saving, which began this month in all Australian states and territories except Queensland, Western Australia and the Northern Territory. Internationally, it's a controversial topic, with Europe looking at trying to abolish it altogether, while the United States is going the other way. They want to adopt it all year round. Now, the Sleep Health Foundation's formed a working group to review the current literature and to form a position statement. And it's also just launched a national survey to ask the Australian public what they really think about daylight saving. The survey is especially looking for patterns relating to postcodes and sleeping preferences, such as whether you're a night owl or an early bird. Polish and French researchers say commercially available water additive with pomegranate extract limits the reformation of plaque and tartar on dogs' teeth after they've been to doggy dentists for a clean. The findings, reported in the journal Frontiers of Veterinary Science, could help man's best friend avoid gum disease in the long term. This study, which was funded by the company that makes the treatment, looked at dental hygiene in 40 dogs with mild gum disease after a professional clean and split them up into 2 separate groups. One group received further treatment, while the other group was given plain water. After a month, during which time none of the dogs had their teeth brushed, the dogs that received the treatment scored 47% lower for the amount of plaque and 24% lower for the amount of tartar compared to the dogs given just plain water. The Therapeutic Goods Administration says reports made last year about 2 boys dying from the COVID vaccines were false. A spokesperson for the Australian Drug Regulator says both reports were found to be hoaxes. Tim Mendham from Australian Skeptics says the claims were part of ongoing disinformation campaigns by anti-vaxxers.
The issue is that, of course, in anything like a pandemic and then vaccines, etc., the conspiracy theorists come out and saying they're being coerced by government into having these dangerous treatments. And so they will look for anything they can to find evidence that what they're being forced to do or what they are rejecting in their particular cases is either illegal or immoral or it's dangerous, right? So they will spread falsehoods readily without any moral control or ethical controls or anything. They will lie through their teeth, and finding them out is the hard thing. But they did find out about a couple of them, just a couple, that were reports in 2022, that 2 boys, one aged 6 and one aged 7, had died because of COVID vaccines. So the Therapeutic Goods Administration, which was in charge of sort of authorising, approving vaccines, went into these claims. They receive a lot of reports of negative side effects or whatever, and they have to log them all. It's part of the duty when you see a pharmaceutical with all these lists of possible side effects. Most of them happen to one person or something, and you wonder if it was actually associated. But anyway, that's the law, and they do that, and then they go and look at them. And there was these, especially when you talk about deaths, they received these 2 reports after the COVID vaccination, and they turned out to be hoaxes. Both of them said that a 7-year-old boy had died from an adverse event following immunisation with an unspecified brand of COVID vaccine, and the separate report in the same year claimed a 6-year-old boy had died after receiving the Pfizer vaccine. Now, what they found out was that these were hoaxes. These things never happened. And the TGA has actually reported the details of 9 deaths in children ranging from 5 to 17 years after COVID vaccine between September 21 and March 23. So that's pretty much as long as we've had the vaccines. But they emphasised that it is correlation, not causation necessarily. Like a death that follows the vaccine is not necessarily caused by the vaccine. And that's what the difference was, that for a start, these 2 children's deaths were hoaxes, right? We're not even quite sure if the kids existed at all, right? And that the deaths they do know about, none of them of kids have been definitely attributed to the vaccine itself. There's been no attribution of deaths because of the vaccine. So that's what they've got to be careful of. But nonetheless, those 2 reports of kids dying, boys dying, were spread far and wide. And then, because, if the authorities report and say, no, these never happened, well, the response from the conspiracy theorists, you're covering it up. So it's a bit of a no-win for the authorities in that case, but at least they pointed out that these 2 kids didn't die. It's like the died suddenly movement that's been around for a while, where suddenly you're getting these athletes sort of dropping, sort of dying because they've had the claims that they've had COVID vaccines. Celebrities, actors, actresses, whatever, the same thing. The trouble is, most of these people may not have had a vaccine recently, they may not have had a vaccine at all, and a lot of them have very good reasons for why they might have sort of fell ill or even died. But that doesn't stop. I mean, one person that was quoted in this died suddenly movement had a car accident, was killed in an accident. So, I mean, it's hardly due to the vaccine.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.